Hello. So this chapter is this is a new chapter, chapter 9, about hypothesis testing. Hypothesis testing is arguably the most difficult, conceptually totally new, and somehow like weird and unnatural way of inference. So it's very difficult to understand and very difficult to teach. So I spent 2 chapters on hypothesis testing. So let's see, let's try. Let me first compare estimation two inference methods. There are 2 statistical inference methods. One is estimation and the other is hypothesis testing. Estimation, earlier I explained this in the estimation chapter. Estimation is an open question and hypothesis testing is yes or no closed question. So estimation is like this: guess what it is, like guess the number. Say, for example, what is the percentage of voters supporting this candidate? Then you have to say like 40%, 50%, 60%, some number. You have to say a number. Or what is the mean gas price of in New York City? And then it's also open question. You have to choose a number to answer, or you may use interval to answer that question. On the other hand, in contrast, hypothesis testing is I said, a closed question. So it's like, do more than 50% of voters support this candidate or not? I think more than 50% would vote for this candidate. So this candidate, I think this candidate is going to win. Is that true or not? Let's check it with data. Or I think the mean gas price these days is lower than $3, right? Or not? Let's check the data. So hypothesis testing is yes or no. I believe something, and is it consistent with data or not? And then, then the statistician has to look at the data and conclude if the belief is consistent with data or not. So that's the basic conceptual structure of hypothesis testing, the difference between estimation and hypothesis testing. So it is a very strange structure. Let me think about some other cases first. Non-statistics examples first. Suppose that I am accused of say a murder. So someone died and say I was accused of that. And I had to go to the court, and but there is not enough evidence that shows my murder. Like if I was the murderer, but there is not enough evidence. Not enough evidence that proves my crime. But but I do not have any evidence to prove myself either, right? So there is everything is murky. Everything is in the gray area. So there is no clear evidence. All the evidences are like incomplete or contaminated. Somehow it's undecisive at all. In this case, maybe a lot of trials will be like this, uncertain, undecisive. Then what should be the verdict? What do you think is the so according to the theory, the legal principles, what should be the correct verdict in this case? The answer is B. If there is not enough evidence either way, you cannot say I'm guilty, right? The judge cannot say I'm guilty. There should be enough evidence to conclude that I am guilty. That's the modern legal structure. So the defendant is considered innocent until proven guilty. I do not need to prove myself innocent. The burden of proof is on the prosecutors, right? So I do not need to show, like, if I don't say anything, still I can be innocent. I may be judged not guilty, right? So this process, this legal system, somehow just on the face value, it looks like, oh, it's not fair in some sense. Innocence and guiltiness is not considered at the same level. So it requires much more higher standard to say guiltiness, right? It's somehow unfair, but it's actually fair, right? In common sense, right? But if you think about the process, like the hurdle for guiltiness is much higher than the hurdle for innocence, right? This kind of decision making is similar to this paradigm shift. So you may have heard about paradigm shift by Thomas Kuhn, science philosophy. So anyhow, let's think about these two scientific beliefs. One is geocentrism and the other is heliocentrism, whether the sun rotates the earth or the other way. You know the truth, but you know, in the old days, people, almost everyone, believed that the sun is rotating around the earth because it looks like the sun is rotating like above us, right? So geocentrism is the prevalent belief in the old days, right? However, now everyone knows the Earth rotates around the sun because there are too many scientific evidences and observations that contradict to the geocentrism, right? So it's only so the geocentrism was believed until it's proven wrong. So also it's pretty similar to the decision making in this trial. And one more thing, yourself making a decision in a store. So you are considering, say, smartphones. You need to buy a new smartphone. You used to buy, for example, let's use my smartphone. I'm using Pixel. It's a Pixel smartphone, Google Pixel. I like it because Google Photo is free. Now it's not free, but it was free. Anyhow, I like it so far. Then when it's about time to change my smartphone, then I will think about this. Oh, do I buy this one or another one? Apple? But I'm not sure. I have not used Apple, so it's uncertain. But it is a safe bet. But a lot of people say Apple is good. The new Apple iPhone is new, good, and like beautiful. See. So then I will maybe, if I do not listen to any, like say, advertisement or YouTube reviews, then I would buy Pixel again because I was satisfied with this. However, if a lot of people tell me why iPhone is better or why Pixel is not good enough, then at some point I may turn to iPhone. Right? So that is a decision making. It is unfair. I do not compare everything in very detail. But there is a kind of status quo, like I have something that in my mind. And from this starting point, I search for something else, and only when I have a confidence in that new item that I will take that. Otherwise, I will just keep the brand I used before, right? Yeah, right. A lot of things are decided this way. So we are doing the same thing in statistics. It's hypothesis testing. So there are two competing hypotheses. We will consider competing hypotheses, like in terms of statistics. In statistics, they say, I believe the true mean is 0, but it may be different from 0. So they are competing. Or the probability is greater than 50% or less than 50%. Like they are statistical statements and they are competing. Those competing hypotheses, and we have to choose one of them and make the decision. And we will call these hypotheses as null hypothesis and alternative hypothesis. The null is the favored, the incumbent hypothesis. So it will be believed until it is proven wrong, right? It's like in the earlier example, it plays the role of incumbent. And we usually denote it as hypothesis 0, subscript 0, null hypothesis. We call this null hypothesis because it has no evidence, and I just believe it, and it will be believed if there is no evidence at all. So just like out of emptiness, it's hypothesis. But alternative hypothesis is the challenger. So we denote it as H1. So that to contrast with 0, it is denoted as usually H1, or some textbooks use HA, but not a big problem. Then given this structure, the results of hypothesis testing is either yes or no. The result should be yes or no. The answer should be yes or no. And one is to reject the null hypothesis, the incumbent hypothesis, and accept the challenger. That is one possible decision. And the other decision is we will keep the incumbent and turn down on the challenger. That's a second possible decision. Here, as I said earlier, we will keep the incumbent null hypothesis even if there is no evidence, right? Therefore, usually textbooks call this accept null hypothesis, but I don't like this term because accepting the null hypothesis sounds like an active, proactive decision, but actually it's not. It's more passive because you may often you have to accept the null hypothesis even if there is no evidence. So then a better expression is to say I cannot reject the null hypothesis because there is not enough evidence. So this is a more natural term. So I will try to use non-rejection, not rejecting H0. So two results are whether you reject the null hypothesis or not. So and if you reject the null hypothesis, automatically you are accepting the alternative hypothesis. And if you cannot reject the null hypothesis, then obviously the alternative hypothesis will be rejected, right? So that's the basic structure. And as I said, one requires a strong evidence, but the other does not. So rejection requires a strong evidence against the null hypothesis. So it is a strong conclusion. If you reject the null hypothesis, then it's a strong conclusion because it was rejected even if it was favored. You are basically, fundamentally, you are favoring the null hypothesis, but you have to reject it. So it's totally inconsistent with the data. On the other hand, you cannot reject H0. It is a weak conclusion because it does not imply there is enough evidence. It may be just because you cannot reject because there is not enough evidence. So it's weak. So as I said, by construction, H0 is favored, and by construction, rejection is a strong conclusion. So a researcher wants to refute the existing theory and present my own theory. So, and want to make it strong. Therefore, usually, to be conservative, usually my own theory is put as alternative hypothesis, and the existing one that I do not agree is put as the null hypothesis. If the null hypothesis is rejected and my hypothesis is accepted, that is a very strong conclusion. So that's what many statisticians are looking for. So again, I'm telling you again, rejection sounds like a bad thing, but actually not. Rejection in many cases, researchers like graduate students, doctoral students in our department is looking for rejection because that is a strong conclusion. So which is important in argument, right? In academic argument. Okay, here is a summary in this analogy. 4 different examples about statistical hypothesis testing, criminal legal system, and paradigm shift and decision making. So there is an incumbent one and challenger. Incumbent, challenger, and incumbent is favored. Challenger is has to overcome the hurdle. Still, if you take the challenger, if the challenger wins, that's a very strong conclusion. That's this is the conceptually basic structure of hypothesis testing. Okay, I will go deeper and like more serious, rigorous statistics in this direction in the next video. See you later.